Math. Hello and welcome to Module 6.1 Equivalent Ratios Part 2. Today we're going to continue working with ratios, but specifically making equivalent ratios. And we're going to look at a couple models and we'll learn what scale is in order to understand equivalent ratios. So the first thing that we're going to do is write down some vocabulary words. So in your notes, we're going to understand what equivalent ratios are. Now, equivalent ratios are ratios that are equivalent and can be simplified to the same values, just like an equivalent fraction. So equivalent ratios are very similar to equivalent fractions. In this example here, you can see that they basically look the same too. The difference being that they can be in any of those three formats that we learned about that a ratio can be written in. And because they could be a part-to-a-part comparison instead of just a part-to-a-whole comparison. Now, we know that these are equivalent because if I multiply the top and the bottom by a specific number, then we know that they're the same value. So 4 times 2 is 8, 5 times 2 is 10. If I multiply my original ratio by 3, then I would get 4 times 3 is 12, and 5 times 3 is 15. Same thing here with my fractions. I can multiply both my numerator and my denominator by a specific number, and then again to get equivalent ratios. Now, this next word, scale factor, is very special to ratios. You may not have heard of it before, but you may have heard of a scale model or a scale drawing or this item not to scale. This is the scale they're talking about. And the scale that they're talking about is basically this right here. Whatever number or factor that you are multiplying a multiplier by. So it's the number that you're multiplying by in which both numbers in the ratio will then be used to form an equivalent ratio. So here you can see that 2/5 or 2 over 5 is being multiplied by 4 on top and bottom. That's my scale factor. Here is another way to show it using this kind of rainbow method. That's the way that I usually prefer when I show scale factor. Now, the easiest way, in my opinion, to show scale, let's just do like an icon here. Let's pick a shape, is on a computer. And this would work for any sort of equivalent ratio. And whoopsie. But here, so I have this little, what is it? Let me click it. There it is. Hold on. There we go. You go back over there. Okay, so I have this picture of these knitting needles and yarn. And right now there is one size to it. If I copy and paste it, this is the exact same size and shape. If I pull on the corners here, I can make this bigger. And because these pictures look identical except for their size, I know that they are to scale. This shape is so much times bigger than that shape. I can do the same thing by making it smaller. Right? Now, I don't know if this is 2 times bigger or 1.5 times bigger, but you can see here the scale, right? We've got tiny, medium, and big, and they look like the exact same photo. When something is not the same, it means that you enlarged a piece of it and other parts at different scales. So I multiplied my width differently than I did my height. Okay, that's kind of what scale is talking about. It also relates to the word proportional. Because these two shapes here are not proportional to these shapes. And it's basically the same thing. It means to scale. We can tell that these 3 shapes are proportional or equivalent or to scale because they look like exactly the same image. All we did to make these pictures bigger or smaller was multiply by a number or a fraction to change their size the same way for every piece of my drawing. In these two, they're not to scale. They are not equivalent because I did not use the same multiplier or scale factor when I was changing its size. Okay. Now that we have an idea about that, let's practice. So we are going to create two ratios that are equivalent to the ratios below. And again, because we know that ratios have to do with a scale factor and a multiplier, we are going to multiply to get that size. Okay. So I have 3 to 11 here. If I times this by 2 and this by 2, I will get 6 20-seconds. That is an equivalent ratio. Now I could do the same thing and times it by, let's do this a little differently. Let's make it equal to. And I'm going to maybe times this time by 3. My scale factor will be 3, and I can make that 9 and 33. So now I have two equivalent ratios, and I did that just by multiplying the top and the bottom, or the two pieces of my ratio by the same number, the same scale factor. Now, when you have a ratio that can be simplified, you are technically dividing, but because our scale factor says a multiplier, what we want to think is that we're really multiplying by a fraction in order to divide. So remember, if I have a number like 6 and I times that by 1/2, that's the same thing as doing 6 divided by 2. Multiplying by the reciprocal, or the fraction, the flipped upside down version, is the same as dividing by that whole number. So if I want to simplify this ratio, and divide by, let's see, what goes into 12 and 18 evenly? 3, I think. What I'm actually going to do is multiply by 1/3, not divide by 3. And that is going to get me 6/4, which is not the smallest form I could do, but that is an equivalent ratio. Now, if I wanted to simplify it even more, I could multiply by 1/2, which is the same as dividing by 2, and get 3/2, or 3:2. This is another equivalent ratio. Now, if I didn't want to do fractions, I could still make equivalent ratios by multiplying by whole numbers on this side and making them bigger. So now I actually have 3 equivalent ratios for number 2. Okay. So for this last one, let's just do 2 of them. On the left, I'm going to multiply by a fraction, and on the right, I'm going to multiply by a whole number. So 6 and 10 have 2 in common, so we're going to actually multiply by 1/2, which is the same as dividing by 2. So I'm going to get 3/5, or 3/5, as my equivalent ratio. And then on the right-hand side, let's just multiply by 2, keep it simple, and I would get 12/20. So now I have 2 equivalent ratios. All right, let's switch it up here. Now, down below, our job is to now determine if they are equal and if they have a scale factor. So we already know how to make equivalent fractions, but let's determine if 2 numbers are equivalent. So the one way to do this is to look at its scale factor and say 2 times what makes 8? 2 times 4 is 8. And then you're going to take it on the bottom and say, does 5 times 4 equal 20? If this is true, then they are equivalent. If it is false, if that's not true, then it is not equivalent. So in this case, it is true. It is, yes, it is equivalent, and its scale factor is 4, because we're multiplying by 4. Now, another way to do this, if you weren't sure how to multiply to get there, is you could divide. If I divide 8 by 2, numerator by numerator, and I divide 20 by 5, denominator by denominator, and I get the same answer, if these are equal, then yes, it is true. So 2 goes into 8 4 times, 5 goes into 20 4 times, and there's my scale factor. So I'm going to show it to you multiple ways for each of these. So for this one, we're going to say, okay, what do I multiply 12 by to get 6? I'm going to multiply by 1/2. I'm really dividing by 2, but remember, multiplying by 1/2 is the same as dividing by 2. Can I multiply by 1/2 or divide by 2 to get 3? Well, that answer is no, because 4 times 1/2 is 2, not 3. So I already know that no, this is not equivalent. Now, if I was doing this, because maybe the fractions confuse me, if I was doing this with the long division like I did above, I would do 12. Oops, sorry, not 12. We're starting with the other number, the one on the right. I would do 6 divided by 12 and 3 divided by 4. And when you divide, this is 0.5. And this guy, 7. 75. 0.75. Those are not equal to each other. Therefore, it is not equivalent. All right, let's do this last one. Now, this last one gets a little tricky because there is not a scale factor I know of that I can multiply 8 by to get to 20, nor 6 to get to 15. So one thing I could do is simplify first, okay? I can divide both of these by 2 to get 4/3. And then multiply over. 4 times 5 is 20. 3 times 5 is 15, so it's going to be a yes. However, that is not my scale factor. Because I divided by 2, my scale factor also has to be divided by 2. So my scale factor would be 2.5. Now, if you're going, Miss Kirkwood, I do not understand how you did that, then pay attention to this right here. I'm going to do long division like I did before. I'm going to do 20 divided by 8, and I'm going to do 15 divided by 6. So 20 goes into 8 2 times. Add the 0, and it goes into 45 times. That's 2.5. Let me move my 16 because it's kind of in the way. Or my 5 and my 6. My 15 and my 6. Man. All right, let's do. Okay. 2 times. Add the decimal and the 0. 35 times. Because this right here is the same, I know they are equivalent, and that becomes my scale factor. So either of these ways will work, either finding the scale factor and comparing, or using division and dividing the ratio on the right by the ratio on the left. Both will work. All right, that was a lot of work that we ended up doing. So to split, we're going to split this video into 2 parts. Come back to see the next video so that we can continue into other examples of equivalent ratios and how to find them.